Good morning, everybody, and welcome to video series 2, video number 4 in our series on developing a winning GMAT mindset. My name is Charles Bibelos, GMAT tutor at gmatninja.com, GMAT Club's resident verbal expert. And for the very first time, I'm going to be talking just about quant today. And for those of you who haven't seen one of these videos before, these are live. If you're not watching it live, that's our excuse for mistakes. No second takes, no editing, no nothing. So apologies in advance if I say some goofy stuff. And once again, I'm used to interacting with people in all the teaching I do. So I'm used to one-on-one. I'm used to hearing back from people. So two things. One is this is the very first time I've just looked into a camera and talked about math. And second, please, 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 we're going to move some questions today. Please give us feedback. So as we go through, please don't be shy about telling us your answers, especially if you're not certain about it. That helps us make this better and helps us make sure we're picking the right things. So today's theme. What we're chasing today is this idea that you need to develop a flexible mindset to succeed on GMAT Quant. And that's the case regardless of whether you're fantastic at math or less fantastic at math. If your goal is a 51, it's absolutely critical that you develop this nice flexible mindset. Even if you're kind of starting at a much lower level, you're somewhere around the 50th percentile trying to claw your way into something higher. Same thing is true. Whether you're looking at mid-level questions, higher level questions, that flexibility is really the heart of what the GMAT's trying to test on Quant. Quick story before we jump into some examples today. One of my favorite students of all time, as far as just somebody who taught me a lot about teaching, a fellow who had, I think, 2 master's degrees. I think one was in engineering and one was in data analysis. His father was a famous physicist, if I'm not mistaken. This guy had just off the charts amazing quant skills. So engineer, super well trained in all sorts of things quantitative, knew a lot more about mathematics than I did. He was stuck at about a 44 quant. And I don't think he ever scored much above about a 680. Why? He had this orthodoxy to the way he did math that just killed him. So a question would pop up on the screen, and he would immediately just start going through algebra. He would do 15 lines of algebra, and it would be the first thing that came to his mind, and it absolutely killed him. Why? So is algebra important on the GMAT? Absolutely. But a typical question, just a mid-level question, picture a 550, 600, 650 level question. Typical GMAT question at that level might have 6 different solution paths. What the test is going after is, can you find the best one? Can you look at that question and figure out what's the most efficient way to do this? What's the way to do this that's the least likely to lead to careless errors? And that's the key to doing really well on those questions. And then as you get to harder and harder questions, maybe algebra is just not enough and there might be only one solution path that might not be obvious. So what we're going after today is if you have a tendency to do mathematics on the GMAT by brute force, first thing that comes to mind, tons of algebra, tons of arithmetic, this is dedicated to you. We're trying to get you out of that mindset, get a little bit more flexible and develop that ability to look at a question, read it twice and go, okay, what are my options here? Invest that 20 seconds in saying, wait a minute, what's the best way forward? Not necessarily the first thing I think of. What's the answer or what's the solution path that's going to get me there the most efficiently with the least amount of pain? So let's get you warmed up with a couple of questions. And again, nothing we're going to do today is going to be super hard. So everything I'm shooting for is kind of at the 550 to 650 level of question. I know that some of you are going to find them pretty basic, especially if you've seen some of them before. But what I'm after here is see if you can find the best solution path and really engage in what's the easiest way through. Is there a way I can save myself 10 seconds, 20 seconds, or just save myself steps? Because if you were with us for the first and second videos in the series, you know that the thing that will absolutely kill you on the GMAT is careless errors. If you miss easy questions, you're in huge trouble. So fewer steps is better for you, less opportunities to make those careless errors. So especially if you find some of this stuff easy, make sure you're really engaging in, hey, what's the easiest way? What's the easiest way? And as we go through, I'll show you 3 or 4 ways to solve each of these problems and try to get you thinking about that flexibility and ways to find the very best way forward. So if you could please shove it good and pop those first couple up. And I'll give you, these are both fairly easy. I'll give you a total of about 3 minutes for these two. And once again, please, especially if you're uncertain about the answer, if you're here on the live broadcast, please let us know what your answers are as soon as you get them. This is great. We're seeing a couple different answers. Keep them coming, guys. We'll give you about 30 more seconds. And even if you only have the answer to the first one, go ahead and spit those out, please. Okay, so for this first question, I mean, I think a lot of you with stronger quant skills are going, come on, really? We're just doing this like basic multiplication, division, subtraction crap. I'm beyond this. Cool. Um, yes, most of you, given enough time, no problem getting this right. The really, really obvious way to do this that I would have been taught in school is, hey, we got some decimals. Let's multiply some decimals together. 1.5 times 1.2. And I'm going to be honest with you, I'm too lazy for this. I don't multiply decimals really ever. It's just not my thing. Takes a lot of time. Easy to make a mistake doing it. Then we got to multiply these two over here. And now we got to worry about the negatives. Take this, subtract that. Then we got to divide by 30. Whole lot of brute force. I'm looking at 6, 8, 10 little steps here. Whole lot of stuff. Whole lot of tediousness. It's the obvious thing to do. Going to take a while. Very, very likely you make a mistake doing it that way. So I'd say the first way you could solve this, first thing that pops into a lot of people's minds is you can just deal with the decimals. Great. Fine, really slow, really tedious. And again, it's not so much that you need that time. You do. Time management's important. But almost more importantly on the GMAT, you make mistakes on easy questions, you're in trouble. Solution paths with more steps, more likely to lead to careless errors, something you want to avoid. What's your second option here? Well, I could turn all these into fractions, is usually the second thing people mention. So now I've got negative 3 halves times 6 fifths minus 9 halves times 2 fifths, all over 30. Once again, I got a lot of little steps here. It's okay. It's going to work. I can get through this. I've just got some 10s in those denominators. It's not that bad. Minus 18 over 10, minus another 18 over 10 over 30. It's not horrible. This is definitely better than dealing with the decimals. It's an option. Not sure how many of you did this or if this led you to the wrong mistake or the wrong answer. This looks like 0 to me, which would get me to C if I'm not paying attention to the negatives. So that's a second way to do it. Third way to do it, even better. Honestly, I'd rather not do calculations if I can avoid it. What do I have here? I've got some negative number right here, some negative number around 2 or so, if I'm estimating, about a minus 2. This is also negative in some sense. You're subtracting the positive. Negative minus a positive. I definitely have a negative number here. So I know for a fact right there, my answer has to be either A or B. Without doing any real calculation, I'm down to 2. Then what? Well, the only difference here is just that factor of 10. Turns out you got a pretty small number up here, right? Negative 1.5 times 1.2, we're somewhere in the neighborhood of negative 2-ish. Same thing here, that's less than half times 4.5, another negative 2-ish. We've got something like a negative 4 over negative, or over positive 30. Negative 4 over 30, it's got to be somewhere in the neighborhood of B. Can't possibly be A. And now I've just answered the question quickly, minimum number of steps, very, very little chance I make an error doing it that way. And there's your third method in this case, which is the estimation. Now, none of these are rocket surgery. Y'all know that you can do these things. The question is, are you giving yourself the time to think about it? So I'm not here to tell you, oh, hey, estimation, it's this revolutionary new technique. You've all thought about it at some point or another. The question is just, are you giving each other enough, or giving yourself enough space to think about that option? Or are you just going through the first thing that comes to mind? Fractions, decimals, slower, more opportunities for an error. In this particular question, estimation, much, much nicer. Now, the second question I gave you guys, much, much easier. I don't know if anybody made a mistake on it on the live broadcast. But even something this simple, there are so many different ways to do it. And they might be really, really small variations on each other. And they might be things that you're not likely to make an error on no matter which path you choose. But almost everything on the GMAT, you've got these options. One thing you could do, most people think of substitution. I do get people sometimes who just want to sort of substitute the first thing that comes to mind. So a bad way to do this might be, hey, I'm going to solve this one for x. So I get 4x equals 1 minus y, divide by 4, and then take this, punch it back in. You can do it. Painful way to do it. You end up with fractions when you really don't need them. Not great. Would prefer that you be a little bit more thoughtful about it. You could substitute, solve for the y here instead. Y equals 1 minus 4x. Great. Now that's much nicer to substitute in. No fractions there. Great. There's a second option. Third option, we could take this bottom equation, multiply it by -2. -8x minus 2y equals -2. And then just add your equations together. No problem. -6x equals -6. Easy. And we can keep going. You could also do a similar thing with that top one. Instead, we could divide this top one by -2. So we get -x minus y equals +4. Add those together, 3x equals 3. Same answer. So what I'm trying to illustrate here is even in something that's the most basic, arguably one of the most basic problem-solving questions we can give you on the GMAT, even here, without thinking that hard, I just showed you 4 different ways to do it. GMAT Quant is all about choices, and the question is, are you making the most optimal choices to save yourself time? More importantly, save yourself those opportunities to make mistakes. Let's pump this up a notch. This next one's one of my very, very favorites. I see such a fantastic range of errors on this one. So go ahead and pop that up if you could, please, Shovik, and we'll give you about 2 minutes here. Maybe about 30 more seconds. Once again, please don't be shy if you're watching this live. Let us know what you're getting for an answer. Okay, good. Looks like we're mostly getting right answers on this one. Makes me happy. I think we had somebody right away who gets a gold star, found the easiest solution immediately. Here's the instinct I see from a lot of people. Hey, let's get a common denominator. Here's the worst thing you can possibly do. Try to get a common denominator for all 3 fractions. Absolute mess. I mean, we can do it. So we get x plus 4 times x plus 1 minus x times x plus 4, and I'm going to run out of space. This is all over x times x plus 1 times x plus 4. I've probably already made a mistake. Absolutely no reason to do this. And there should just be a red flag that always, a little alarm bell that goes off in your head whenever you see something getting this tedious and go, wait. There's got to be a better way. Remember that every single question on the GMAT, it can be done in 2 minutes. Whether or not you'll find the way to get it done in 2 minutes is another question. It can be done quickly. If you see this kind of bloodbath happening, stop and go, wait a minute, there has to be a better way. Slightly better way. So that first method is, we'll call it bad algebra in this case. Second way, you could just get a common denominator from this first, from the left side alone. Seems a little bit more reasonable. So we get x plus 1 minus x over x times x plus 1. This doesn't work out too badly. So sure, you've got two different denominators here, but watch what happens in the numerator. X plus 1 minus x, we just get a 1. So now it has to be true that these denominators are equal. You can set those two things equal to each other. Go ahead and solve. Fair amount of work, but not bad. We'll call that better algebra in this case. And once again, the GMAT's going to reward you for thinking kind of a little bit outside the box. Remember, the section's not called math, it's called quantitative reasoning. And I roll my eyes at that a lot. I talk about it a lot on verbal. It's not reading and grammar, it's verbal reasoning. Same idea on quant. Not math, it's quantitative reasoning. Why? What are they trying to do? They're trying to see if you can find those better solutions, even if it means kind of going against your algebraic instincts. Somebody correctly said, you can't have a 0 in the denominator ever. So your answer here cannot be 0. X cannot be -1. X cannot be -4. And now you just have two different answer choices. You can punch one of them in for X, very minimal amount of work. That's going to get you the right answer pretty quickly. All right. Let's apply the same thing next to a little bit of geometry. This one, again, isn't terribly hard. I'm just going to ask you the area of a triangle. Not a big deal. You've done that hundreds of times in your life, if not thousands. What I like about this particular question is there's probably 3 or 4 different ways to do it. And if you get too rigid and you get locked onto one of them, once again, it can cause you a little bit of trouble. So if you could put that one up, please, Shovik. And we'll give you, should I be mean and restrict your time a little bit? Let's go ahead and give you 2 minutes on this one. And then the next one, I'm going to make you do it really, really quickly and see if you can cut straight to the quick solution. Give you about 2 minutes on this one. And I apologize, guys. The answer choices are actually wrong for this. I made some changes to the question at the last minute. So please ignore those answer choices and just, if you could please, just post your answer, ignore the answer choices. My apologies. I made some last second changes and I don't think the correct answer is even an option. Give you about 30 more seconds. If you have an answer, go ahead and put it up if you could, please. Seeing a few 12.5s. If you're getting something else, please let us know. Especially if you're uncomfortable, please let us know. Okay, let's go ahead and take a swing at this. I can think of 3 different ways to do this, and what we typically get out of at least some subset of our students on this is the first thing they'll think is, hey, I see something here that's kind of the flat surface. That must be the base right here. So how do I get the height? Well, I drop this down, and there's my height, and this is great. So to get the area of a triangle, I always want 1/2 times base times height. This is great. Now, the problem is if you're not thinking a little bit about what you're doing, if this is the path you choose, this is actually really bloody hard because first you got to get the length of that base. It's doable. It's not that big of a deal. So this is 7 here, and this is 1. So this base, this has to be square root of 50. That's all right. Now that height, how are you going to get that? It's kind of a mess. You can get it. You can find the slope of this thing. This is perpendicular, so then you can find the slope of that. It's doable. It's going to take you about 5 minutes unless you're really, really good at this stuff. Really, really tough way to do it. What is the GMAT after with questions like these? It's not that they're really testing you on, do you know how to get the area of a triangle? You all know that. But it's, can you find the different ways that you might get the area of a triangle? So here's one, not very efficient. Second option. If this turns out to be a right triangle itself, I'm pretty happy, right? So I could test that. And now, obviously, I don't know for sure if that's going to work, and I'm going to have to put some effort into this, but it's a second option. So I could say, well, I already know from a second ago that this is root 50. This side, well, this is 3, and this is 4, so this is 5. Same idea here. This is 4, this is 3, so this is 5. So now what do we have? We've got a triangle that's 5, 5, that root 50 turns into 5 root 2. Hey, look, it's a special triangle. That's a 45, 45, 90, isosceles right triangle. So now we know that that's a right angle. So there's your second option. It's another version of 1/2 base times height, but it's basically find the 90-degree angle. Now, that might take you a little bit of time, and if we don't know ahead of time that that's a 90-degree triangle, and of course we don't, you can end up blowing a bunch of time here. So not a bad option. Third option, and I'm going to redraw this a little bit so it's cleaned up. So here's your 7, 0. Third option, and there's actually a couple of GMAT questions out there where this third option is actually pretty much the only way to solve it quickly. Let's turn this into a rectangle. So kind of this phantom point up here is going to be at 7, 4. So now I've got this rectangle. I know that the entire rectangle has an area of 28. Easy enough. I want this triangle in the middle. So as long as I get this triangle, easy to get, this triangle and this triangle, I can get that entire rectangle, subtract out 3 triangles, and then I've got the remaining triangle inside. Turns out that these are pretty easy to get, and it's going to lead you to the right answer pretty easily. So this right here is, this is 4, this part's 3. So what we have here is 6 for the area of that one. This one here is going to be 4 and 3 again. The area is 6. This is 7 and 1. The area is 3.5. So easy enough. We get that area of 28 minus 6 minus 6 minus 3.5. And unless I made a mistake, that gets you to 12.5. So third option, we'll call it the phantom triangle method. Very technical term. That works too. I would argue in this case, either number 2 or number 3, equally viable, whichever one you prefer, no problem at all. But you can imagine that as we get harder and harder questions, as we get data sufficiency questions that get tough, maybe the ability to think of something like this is exactly the thing that's going to give you a shot if the other two methods don't. Okay, so now I'm going to get into a couple questions that where at least on one of these next two, I'll put two up on the board at the same time. At least one of these next two, I'd argue you really can't solve it through brute force. Here, at least you have the option. Either of these first two methods will work. Third method that's a little bit more out of the box, that'll work as well, maybe a little bit more efficient. In this case, I'll give you two questions, very, very similar, I think, in spirit. One of them is just going to be inefficient if you don't find the good, smart solution to it. And the second one, I'm not even sure you can reasonably solve it through brute force alone. We'll give you about 3 minutes or so on this next pair. And please don't be shy, guys. Let us know if as soon as you get answers to either of them. Give me about 30 more seconds. Okay, so let's start with that top one. Your instinct here, this is actually a little bit similar to the very first one we did. So I'm looking at X, and if you look at your answer choices, we just want to know something about X, Y, and Z in relation to each other. It's not asking us to actually calculate the values necessarily. We just want to know which ones are bigger or which ones are equal to each other. If you have an instinct here to just multiply these decimals out, probably not a great instinct. Really, really, really easy to make a mistake here. Super easy to make a mistake. Again, I can put that decimal in the wrong place. Easy enough. 8 times 8 is 64. But I could do this. I could do this. Neither of those are right, obviously. This is right, but it's a pain in the butt. Now it gets even worse. So now I've got to divide 1 by that thing. So long division, depending on what part of the world you're in, this might look different, but holy crap, this is a mess. And then this isn't that great either. 0.92 times 0.92. I'm too lazy for that stuff. Not going to do it. So that's one solution. You could just go brute force, do the decimals. Second solution path, you could turn these into fractions. I'm not sure that it's that much better. It's better. It's not that much better. That thing squared, not that great. Take the reciprocal of that, still not that great. 1 minus that thing, still not that great. Again, it's better than the decimals, not great. Even better. So what I'll usually say to my students if we're going through this question is I'll say, hey, tell me about x. No, in words. Let's imagine that I'm a relatively smart 11-year-old. I don't know how to do algebra. I don't know how to actually multiply stuff out yet necessarily. You would at age 11. But let's say that I don't know how to multiply stuff out. I don't really know what numbers are, but I can understand size. I can understand kind of the general idea of size. I know what a fraction is. I know what it means to talk about, let's say, a fraction of a pizza or something. Okay, well, what's x? Small number. It's a tiny fraction. You square it. You get an even tinier fraction, positive. What happens when you take 1 and you divide it by that tiny fraction? Like, it's really big, right? And that's positive. This is a positive fraction. Z, well, I get 0.92 in here. I square it. It's going to shrink a little bit. So this thing is still some sort of decimal or fraction, positive. I subtract 1 from it. What do I get? I get a negative number. And with no calculation at all, I'm out of here. So I know for a fact that y is the biggest, x is the next biggest, and z is the smallest. Done, mission accomplished. Super, super, super simple. And again, very much part of the design of the test. Why is the test time pressured? There's a cynical answer, which is that's just the way we write tests, and it's easy to administer if we know how long you guys are going to be in the test room. That's a cynical answer. It's part of the answer. But the other part of it, I think the GMAT does a very artful job, whatever else we might think of the GMAT. They do a very, very artful job of giving you questions, especially on quant, that are going to reward you for efficiency, reward you for flexible thinking. The more flexible your thinking is, 30-second solution here, quick. If you're inflexible, jump straight to the decimals, might take you 4 minutes. Okay, and now we get to one that's actually a little bit tougher. This is one where without that flexible mindset, I'm not sure you can really solve it at all, not reasonably. Every once in a while, I'll get somebody who actually somehow finds a common denominator for all this stuff. I'm not sure you can do it in less than 6 or 8 or 10 minutes. It takes a really, really long time. Not going to be a pretty sight. And immediately when you see something like this on the GMAT, you should think, wait a minute. Even if I try to add up all of these series of numbers, I've got 20 different numbers there. I'm going to get common denominators for 20 different fractions. Immediately that should set off alarm bells in your head, and you should think, wait, there's no way this is the way forward. Now in practice, if you can't find the better way forward, and we talked about this quite a bit in our first and second webinars in this series, get out, guess, move on. Don't waste 6 minutes on it. Not going to be worth it. Going to cost you a whole bunch of other questions. No question is worth 6 minutes. You don't see the good path here, guess, move on, spend your time elsewhere. Now, ideally here, so the question's asking you which of these is the greatest. So it's never asking us to calculate necessarily. You don't want to know the value of the greatest of these sums. All you want to know is, can I find the one that's bigger than the others? Now, logically, it should be fine just to say, for example, if I know that something is larger than D, doesn't matter which answer choice I know is larger than D, as soon as I know that D is smaller than something else, I can eliminate it. And if you kind of apply that principle throughout all 5 of those answer choices, you can be out of here in a big, big hurry with a minimal amount of calculation, really almost none. So I'm going to pick on the ones that look the easiest to compare first. So I don't necessarily want to mess with the exponents and roots right away. My eyes go straight to D and E. It's not the only way through, but to me, that looks the easiest. So I'm looking at this 1 minus a half. Well, that just gives me a half here. So a half plus a third minus a fourth. In D, E, I get a half plus a third plus a fourth plus a fifth. Only difference is that last couple of terms. So I know for a fact E is bigger than D. D is not my answer. So now I'm going to compare, let's compare E with B. Those look similar enough. What happens when I square my denominators? I make the denominators larger. So each of these denominators is larger than the denominators in E. That means the fractions are smaller. Fractions are smaller, E's bigger, B's out. C is kind of the same idea. Each of these denominators is bigger than their counterparts in E. So once again, I know that if the denominators are bigger in C, fractions are smaller, C's out. And now all I've got to do is compare A and E. Only difference is we've square rooted those denominators. That makes the denominators smaller, fractions are bigger, these are bigger, E's out, A's my answer. I did one tiny little calculation, and that is absolutely it. So this is the heart of it. GMAT loves this stuff, absolutely loves this stuff. Again, not necessarily this exact format of question, but this general idea of the more flexibility, the more you can kind of take that step back, invest 20 seconds, 30 seconds at the beginning of the question to ask yourself, how good is my solution path? Is my plan to kind of go through and add a bunch of fractions up? That's my plan. That's a crap plan. Maybe I should either guess on it or find something better if you can't. Guess on it if you can't find something better, but give yourself that 20 or 30 seconds, invest that time going, wait a minute, is there a better way? Can I find a better way through this? And they reward you for that flexibility in thinking over and over and over. Okay, this next one I actually think is I might argue there are fewer solution paths on this one. I would argue there's a very technical way to do it, which is fine. For some of you, that's going to be a perfectly efficient answer. And there's a second way to do it that I think is much more efficient. There isn't quite the range in this case, but let's see if you guys can find the quicker way to solve this one. We'll give you about 2.5 minutes. And once again, please don't be shy, especially if you're uncomfortable with your answer. Let us know what you get. This is great, starting to get a nice mix of answers here. Um, Let me start with kind of the good orthodox algebraic way to do this, which again, for some of you, your algebra is so strong, this is going to be totally fine. So salaries went up by 3%, benefits went up by 5.5%, the total employment cost went up by 3.5%. Great. Well, what are we really talking about here? Well, salary plus benefits is going to equal your total employment costs. Fine, there's one equation. And then we can say, well, we know that 1.03 times S, and sorry, I'm losing my voice, 1.055 times the benefits is going to be equal to 1.035 times the total. And now you're actually okay here. Excuse me. Give me just a moment. And this is the problem with live broadcasts. If I lose my voice, you guys are screwed. What we're after here, we're trying to figure out what percentage of the employment costs are fringe benefits. So in some sense, you're looking for that ratio of salary to the fringe benefits. So we can get there from here, no problem. We can take this S plus B, sub it in over here. 1.03 times S plus 1.055 times B equals 1.035 times S plus B. And I'm not going to go through the rest of this algebra because it'll make all of you fall asleep, especially those of you who are joining us in Asia really late at night. Thank you so much, guys, for being here with us at nearly midnight. We can go through this algebra. It's going to be fine. You're going to get something where you'll be able to solve this for the ratio of S to B. You'll get some numbers there. It's going to be just fine. But again, notice all of these little steps. There's just that opportunity that you're going to make some mistakes there. And certainly it's going to take you a little bit more time, especially if you're not completely amazingly fast, super efficient with your algebra. Not everybody is. No shame in that. You can get to a great GMAT score being just very good at algebra. You don't have to be masterfully quick, because again, the GMAT's going to reward you if you find the other way to get things done. So quickly here, I'm going to turn my microphone off and drink some more water. Sorry again, guys. All right, so a different version of the question. I'm a former bartender. Let's make the world's most disgusting cocktail, a mix of Midori melon liqueur and moonshine. And we know that moonshine is 55% alcohol. Midori is 30% alcohol by volume. And we're going to mix those into a delicious cocktail that's 35% alcohol. Now, a lot of you have seen this. There's variations of this. Most test prep companies do a version of this. It's a weighted average kind of technique. They can get you to an answer really, really quickly, because what is it that's going to determine that strength of the mix? So the GMAT's phrasing on this might be, we have solution A and we have solution B. Here, I prefer alcohol. We've got our Midori, it's 30%. We've got our moonshine, it's 55%. We mix them together, we get this nice cocktail that's 35%. First thing I'm thinking here is, well, I know I have more Midori. This is the moonshine. Second thing I'm thinking here, well, the relative distance of each of these endpoints from that weighted average is going to determine how much of each component is there. More moonshine, we're going to be closer to the moonshine. More Midori, we're going to be closer to the Midori. And it's going to be a nice linear weighting. So when I look at these distances here, it turns out that the Midori is 5 away from that cocktail. The moonshine is 20 away. So I know that my ratio is 5 to 20, 1 to 4. And I know that because we have more Midori, this must be the ratio of moonshine to Midori. So that's great. I know that the ratio of moonshine to Midori is 1 to 4. That means 4/5 of it is Midori. We get to 80% in a big hurry. Much less algebraic. Again, nothing wrong with the algebra. It might take you a little bit longer. If you can master something like this, where you just recognize the intuition, it's a linear weighting. The more you have on one side, the closer that average is going to be to that side. Great. Now we can actually apply this here. So we want to know what percentage of those total employment costs are the fringe benefits. Well, we know that the salary went up by 3% here. We know the benefits went up by 5.5%. We know total, we went up by 3.5%. And check this out. It's going to be exactly the same thing as this. I just made the numbers look nicer over here. So here's your salary. Here's your benefits. We know that we're going to have more salary. This gap is 0.5. This gap is 2 I'm sorry, it's 2, not 2.5. So we know our ratio is 0.5 to 2, better known as 1 to 4. And again, we know that that's benefits to salary. And so we know that 80% of those total employment costs were salary, 20% were benefits. So much, much simpler. Again, it's not always going to be the case that you can find some little shortcut like this that's going to be kind of this specific. But if you can master some of these little things here and there, they're going to help you quite a bit. Much less like you're going to make a mistake than you would with the algebra, especially if you're able to engage that intuition. You know for a fact right off the bat here, the fringe benefits have to be a smaller component than the salary. Why? Total went up by 3.5%, salary went up by 3%. Has to be the case that it's going to be the majority of the employment cost will be the salary. Okay, got about 7 minutes left. Let's do one more. And this is another of my very, very favorites. I think there's probably 4 or 5 different ways to do it. We'll give you about 90 seconds on this one. Let's see if you guys can get to the answer quickly. And Shovik, if you could put that next question up, I'm not seeing it on my screen here. Sorry for the wait on that. We'll give you an extra minute here. About 20 more seconds on this one. I know we had a freeze in the live feed, so give you a little extra time. And if you have an answer, if you have a cry of anguish, either way, please let us know. Okay, starting to get a variety of answers. That's fantastic. So let me start with kind of the what I think is the most obvious way to most people. So the version that we see out of our students the most often in kind of their initial attempt at something like this, they'll say, "Hey, okay, I like algebra, so I'm going to call the first integer x. So I can go x plus 1 plus x plus 2 and so on. And so you get this kind of complicated expression. You can set that equal to 240. It's not that bad. So you get what? 5x plus 1 plus 2 plus 3 plus 4 equals the 240. You're okay here. You'll get to an answer. It'll work. Even better, though, since I know that these are consecutive integers, I absolutely know that that average, so the sum of the first 5 terms, I can get to the average, which is going to be the same as the middle number, same as the median. Whenever you have a symmetrical set, many of you know this already, mean is going to be equal to the median. So I know here that the average of the first 5 is going to be 240 divided by 5. So that's 48. That's going to give me the middle number of the first 5. And now no problem, I can write them all down. Next 5, just keep counting up. All I have to do is add these guys up. No problem, should get 265. There's a second way to do it. Third way actually kind of leverages this guy a little bit. So what do I know here? So I've got my x plus 1 plus x plus 2 plus x plus 3 plus x plus 4. Now the next one here is going to be x plus 5, x plus 6, and so on. Check this out. All of these numbers in the second 5 are going to be 5 bigger than their counterparts in the first 5. So whatever that very first term is, the first number in the first 5 numbers, terrible phrase, the very first number in that first 5, you add 5 to it, you get the first number in the second 5. Second term in that first 5, add 5 to it, you get the second term in the next group. So we're adding 5 to each term. We're doing that 5 times. All I have to do is add 25 to my original sum, 240 plus 25. I'm done. So right there, we can probably think of a couple of other ways to do it. Right there, 3 different ways, 3 different levels of kind of number of steps. If we kind of do just the algebra here, again, it's going to work just fine. It's going to involve a lot of steps, opportunities to make errors. Here, going to work a little bit better, fewer opportunities to make errors a little bit quicker, fewer steps. You still have to add these numbers up. Depending on whether you can find the quickest way to add those numbers up, might take you a little bit more time, might give you an opportunity to make a mistake. Here, if you just recognize all I have to do is add 5 to each of the terms in the first sequence of 5, so I add 25 total. That's it. One very simple calculation. Almost no chance you make a mistake. Okay, so we'll wrap this up. I'm sorry again for all of the technical glitches and my my voice glitches today. What's my point here? The thing you want to really, really fight for, especially if you're self-studying, is really, really fight for that ability to find different solutions to the same question. So whenever you're going through your homework, so our very first video of this second series was about how to become your own GMAT tutor. We talked quite a bit about using error logs, and we talked about this idea that you always want to very, very, very meticulously track everything you do. If you miss a question, you want to redo it later, not review it right away, but redo it and see if you can figure out where you went wrong. One of the things I want you to add in, if there's anything that takes you a long time, flag it. I think most of you have an instinct to do that. If something takes you 3 minutes, 4 minutes, 5 minutes, if it feels tedious, you get that feeling that you didn't do it the best way, whether it's on a homework set, official guide, practice test, make a mark, come back to it and start asking yourself, what are the ways I could have inserted more flexible thinking here, thought about different solution paths, and was there a moment where my failing was that I didn't invest enough time up front? A lot of the secret to the GMAT, and it really sounds counterintuitive, is the more time you invest in that question up front and asking yourself, wait a minute, have I read it twice? Have I read it correctly? And more importantly on the quant, have I seen every possible solution path? Have I found the best solution path Or am I just jumping in brute force, first thing that comes to mind? It's going to slow you down in the long run. It might cost you 20 seconds, 45 seconds, 2 minutes on a question. Over time, that adds up, gets you in big trouble on the timing, and probably more importantly, gives you opportunities to make those errors. So ask yourself as you're reviewing your work, as you're redoing your homework on the quant, was there another solution path I should have seen? And should I have invested a little bit more time initially reading that question one more time, asking myself, is my path any good? Okay, that wraps it up for today. We will be back to verbal. Hopefully my voice will be back. We'll be back to verbal next week. We're going to talk about sentence correction. And in a sense, it's going to be a little bit related to this. Today, we talked a little bit about priorities in some sense on quant. We're going to talk about priorities on sentence correction. Are you thinking of the best solution paths right away? Are you finding the stuff that's important right away? Or are you kind of floating around finding things that are going to be a waste of your time? So we're going to try to get you sharper at finding the most important issues on sentence correction. That's going to be next week, same time on Wednesday. Actually, daylight savings time here. Keep an eye on GMAT Club. Hit that subscribe button. I think if you're in other parts of the world outside of the United States, we're actually going to be starting an hour earlier because of the time change here in the US. So it's going to be 9:30 a.m. Pacific time US. And that's going to be an hour earlier for most of you elsewhere in the world. So we'll see you next week, 9:30 Pacific for sentence correction. And then after that, we'll have a data sufficiency lesson the week after that. See you guys next week. Thank you so much for putting up with our glitches and my shaky voice. And have fun studying, everybody.